Excellent. All right, and with that, I turn it over to Kattni. Kattni Rembor is a board member, and she is also a member of Adafruit, and will be talking with us about CircuitPython and all the Pythonic goodness in the circuits.
All right. So, CircuitPython. A little bit about me. I am an independent contractor with Adafruit Industries. I work as an embedded software developer, a technical writer, and a community builder. Adafruit, about a year ago, decided that they wanted to fork another version of Python called MicroPython, which was designed to run on microcontrollers. And MicroPython is a very low-level language, and they decided they wanted to make a much higher-level version of it, a version that works for teaching, that is much more accessible, and that is how CircuitPython was born. So I am here to talk about that today. All right, so we're going to talk about what is CircuitPython and why would you use it. We're going to discuss the CircuitPython community. It's a huge part of it. Compatible hardware. We're going to talk about getting started with it, installation, creating and editing code, the serial console and the REPL, which are a way to interact with your microcontroller while it's running CircuitPython, and then various parts of CircuitPython. We'll start with some more beginner stuff and move towards some more complicated things. So what is CircuitPython? It's an open source derivative of MicroPython. It's designed to run on microcontrollers. Like I said, it's a higher level programming language. And part of the amazing thing about it is it comes with an incredible supportive community. You decide to start using CircuitPython, you're not on your own. There are plenty of ways for you to either be part of that community or to learn from that community. They're available for questions, they're available for help, and available just to walk you through projects or any sort of stuff like that. It's designed for learning. It lowers the barrier for entry. You don't have to have any programming experience to get started with CircuitPython. You get the board, you plug it in, you use it, you write code on it, it works. That's the goal. It works with several Adafruit boards and a particular chip that is on various boards that are not necessarily Adafruit specific. So why would you use it? You're new to programming. It's a great place to get started. You can get your projects up and running very quickly because there's no compiling, there's no OS, you're not installing any extra stuff on your computer except for a plain text editor or possibly a terminal type program if that's the direction you want to go. You can easily update your code. The code is live on the board. You plug it in, you update a file on this board, and it automatically runs. So anything you're doing, you get immediate feedback. There's solid hardware support. There are libraries for many sensors and boards. The idea being that you can import a library and you can immediately use that sensor. You don't have to write extra code to do it. All you have to do is write your program and it runs. There's actual file storage on the microcontroller itself. So your code is right there. So you have your project and it's self-contained basically. You can plug it into your computer, you can edit it, you're right there. It's Python. Python's a great language. It's one of the fastest growing languages out there. And for the most part, CircuitPython is completely compatible with Python. If you understand Python, you will be able to move into CircuitPython very quickly. And it's open source software on open source hardware. Anybody can copy it, can edit it, can change it, can fork it on GitHub. Anything that you want to do, you can. And that's one of the great things about it and one of the things that has made it so great. So the Adafruit CircuitPython community, I want to talk about this. It's an important part of everything. And it's not just about support. It's about contributing and about being part of it. Everybody's welcome. Any level of knowledge, you could be a complete beginner or you could be a seasoned programmer, you are welcome into the community and there is always stuff for you to do. There's a Discord server where a lot of people hang out, usually 24/7, and it's basically a giant hackerspace online. A lot of questions get answered there, a lot of support happens. There's the forums where there are actual like paid support people to help you out if you can't quite get the answer you want on Discord. There are learn guides for every single sensor or board you buy. So you buy that board, you don't know what you're doing with it, it doesn't matter. You click a link and you will be able to walk through steps that will tell you how to use it and what to do. You're not starting cold. So that's one of the great things is when you buy these boards, you're not expected to know everything there is to know about it. You can know nothing and get started with a project with making things blink, which is what we will be doing, that sort of thing. And then everything's on GitHub. All the code is on GitHub. CircuitPython is available on GitHub. And that's where a lot of the contributing happens if you want to contribute directly to the code. So if you are a programmer or you want to get started in programming, there are issues on CircuitPython, on the CircuitPython repo itself that are everywhere from a very great beginner issue like there needs to be an update to a typo in some documentation. That's a way you could contribute, all the way up to if you want to contribute to the core code because you've been programming for 20 years. So the compatible hardware is, what did I do with it? So this is the Metro M0 Express. It's this is the most complicated board, or at least beginner-friendly board that we have, in the sense that you will be wiring everything that you need to do with it. It's Arduino compatible, in the sense you can actually run Arduino on it, but it's also the Arduino form factor. So any Arduino shields will also work with it, and if you are interested in writing libraries for your Arduino shields, boom, they work. Moving backwards down the list, we have the Feather board, which is a little more interactive, has a lot more things that are built to work directly with it. All of these, like I said, run CircuitPython the same way. From there, we have a few other options. There is Gemma, which is designed to be more for wearables. Those are alligator clip-friendly pads, or they can be sewn on.
Kattni, is that a full computer on there?
Yep. It's a microcontroller. It's an all-in-one computer. Gets even smaller. This is Trinket. Trinket comes with headers to be soldered on to use it with a breadboard if that's what you want. But the premier learning board that Adafruit has designed is called Circuit Playground Express, and it has, of course it's not going to focus, it has built into it something like 15 sensors or lights or switches and buttons, and basically it's designed so that you can take that and you can learn about electronics, you can learn about programming. You don't have to have anything to wire, you don't have to solder anything, you don't have to know how to do those things. It's very, you plug it in, you get started, you've got all these different things to interact with, but it can move into being in part of more complicated projects as well, so you're not limiting yourself by starting with this board. There's also the ESP8266, which is a totally different type of chip than is on the rest of these. And it does run CircuitPython, however, it doesn't work quite the same as the boards here, which are running, to get into the technical part of it, it's an Atmel SAMD21 chip, and the Feather, the Metro, and the Circuit Playground Express all have SPI flash on them, which means that there's extra storage. Trinket and Gemma do not. They are too small at the moment to hold the extra chip, so there is less, you can run less stuff on it at a time. With the M0 chips, you can run quite a lot more. And with the ESP8266, you're limited as well. There's not a SPI flash chip on that. So, getting started. This is a brand new board. I've done nothing with it. This is the bag it came in. And all I would need to do to get started is plug it in. There's demo code already on it, which makes the LED turn different colors. If I touch one of the pads on it, it's not going to focus. One of the pads on it, it will turn on the little LED. And as well, it has things that are printing out right now to what's called the serial console in the REPL, which we'll look at later. But the key right now is that I can change what this is doing All I've done is plug this in. Get all this to work. 5 demogram movies. Alright. So here's what the code looks like. This is probably not readable. Hold on.
So that looks like a thumb drive to the
Yes.
computer?
Yes, it
You're just
does.
editing a file on a thumb drive?
Mm-hmm. When you plug these in, let's see if this works. Is that better? Still good.
Better.
That's much better.
Alright, so when you plug it in, it shows up as CircuitPy on, as though it is a USB drive. And you can open a file from it. Main.py is what's running on here by default. And you get the demo code. And what I'm going to do is change, right now the LED on it is changing colors. And I should, if I remember the format correctly, be able to just make it red. All I did was open that and change this file. And we're gonna get into this in much more detail, but this is how simple it is to get started with CircuitPython. And every single one of these boards that I showed you, all of them will show up as a USB drive, and all of them will work exactly the same. So, let's get into the rest.
Is it recommended to make a backup of how it looks when you get it, in case you make a mistake?
Those files are available for download. So if you did want to return it, it's again as easy as just dumping some files back on it. Even if you make a mistake, you can always go back, you can always change it, and it takes quite a lot to you can't really break it. It's just your code won't run. So these files are all the default files are available for download on the Learn Guide that goes with the board. So, installing CircuitPython. So I'm gonna go over it and then I'm actually gonna walk through it. You're gonna download the latest version from GitHub. When you double tap, there's a reset button on the board. That we'll see very small on here. So the little button down here is a reset button, and to get into to install CircuitPython, you need to enter the bootloader.
I thought you said the CircuitPython came installed on the...
It does. You may want to update it if you've got a board that's older, or at some point you may have. It's possible the files on the board can get corrupted if you were to unplug it, for example, in the middle of writing a file. So you may want to reinstall CircuitPython at some point.
And can you install CircuitPython on another plain vanilla Arduino or something like that?
There is one, I believe it's the Arduino Zero, does support CircuitPython. Arduino otherwise does not support CircuitPython.
Not the Uno.
No. It's designed for these boards. It's not necessarily designed to be like an across the board thing. The Metro will actually now that I think about it, this will be shipping with CircuitPython soon. So now it's true, all of them do ship with CircuitPython now. For a bit they didn't, but in case you wanted to update it in the event that you got a board that was shipped to you before 2 weeks ago, which is the most recent version. When you enter the bootloader, it will mount as a drive called board name boot, which essentially looks like whatever name the board is. So this is a Trinket, so it's Trinket boot. This would be C-Play boot because it's Circuit Playground Express. You're going to drag the file you downloaded to the drive. It automatically resets, and CircuitPython is installed. Your drive will show back up again. So let's go ahead and... So this is the website, the GitHub site for CircuitPython, which I believe I included the link at the end. And right now we're working with the Trinket M0. That's what this board is right here. So I'm going to download the Trinket M0 version. downloads, it downloads a UF2 file. That is the file that is, CircuitPython is a UF2 file, and that's what the bootloader is designed to install. All I'm going to do is drag the CircuitPython Word file, the UF2 file, if I can do it. New computer, sorry. Apparently I'm not going to drag it. Alright, I have no idea why that's not working. So I would drag it over.
Copy and paste it.
Yeah, I don't know if that works. I have no idea why this isn't working. I apologize, I got this computer about a week ago, and apparently, and I've been using an extra mouse, which I guess I should have brought. So if I drag it over, it automatically resets, and the CircuitPy drive will show up again. Similar to what's going to happen right now because I hit the reset on the board. My CircuitPy drive is back. Most of the time your files are still there. It's always good to back up your files before you update CircuitPython though. It's just a good practice to get into because like I said, the files on these boards can become corrupted if you unplug it or it resets while you're writing to the board.
You're talking about backing up the files you've created.
Mm-hmm, yes. So, creating and editing code. You can actually edit the code in any plain text editor. So Notepad on Windows Text Edit on Mac and gedit on Linux will work. There are code editors. Atom is one that is a lot of people use. PyCharm is what I use. As well, there's been a new editor that was written specifically for these boards called Mu Editor. The cool thing about Mu Editor is it automatically connects you to the serial console, which is we'll be looking at in a bit. So you don't need to use Screen or PuTTY if you're using Windows to connect to that. And it automatically finds your board. It doesn't have the same level of code editing and code completion and all that stuff that an actual code editor would have, but it's really good if you're just getting started. So we are going to do what is often considered the CircuitPython Hello World, which is blinky. Get started on this one. All right. You end up doing this often, where you rename your files that it runs. Right, demo code. So, what's going on here is CircuitPython will run files by default. That's how it does the automatic reset, and that's how it automatically runs your code. There are 4 files that it will run. It will run main.txt, main.py, code.txt, and code.py. The order it looks for them in is actually opposite, I apologize. It's code.txt, code.py, main.txt, main.py. The .txt files are for people who don't have a code editor and don't have a way to download one. But essentially it runs it automatically. So when I created this code.py file just now, it switched to running that instead of the main.py file that is still installed on the board. And there's nothing in it, so it's doing nothing. So, I am going to write up what we call Blinky. It's our hello world. And then we will discuss it. All the stuff that keeps popping up with auto-completion, that's something that comes out of using a code editor versus using just a text editor. I highly recommend it. That's it. Makes the LED blink. The reason this is our sort of our hello world is that every single one of these boards, while there are different pins on all of them, every single one of them has a red LED on D13, and therefore the same piece of code, this version won't, I'll explain why in a second, but the same piece of code will run on all the boards, and it's one of the only pieces of code that, as is, will run across the board. So, it's as easy as that. 8 lines of code, and I have a blinky light.
You don't have to end the while block?
If I wanted to do something else, I can do, it's just, it loops eternally. If I wanted it to not be looping, then I would need to end it and put something else in there, but.
That end the while block is a Python thing. Because of the indentation, it ends implicitly, and so the while block extends to the end of the indentation in Python. There are no curly cues around it. Because those 4 lines are indented, they're in the while block. The next line that comes back to the same level of while will be outside the while block. Right, that's Python.
How did we get from typing the word red to meaning B13 on this board?
So that's what I'm going to discuss in a minute. The difference is, and I'll show you this file. This is the version that works across the board. There is a library written for this particular board that is designed to simplify everything. It does all of the initialization. It names everything very obvious things. So the easiest version of Blinky comes with this particular board. This is the one that is D13 and does across the
So
board.
CPX is the support library for the Circuit Playground Express.
It's actually, CPX itself is what's called a singleton. It's at the bottom of the file so that you're not importing a much longer name, but it's actually, the class itself is Express class. But you don't have to, you just import from Express class CPX, and that way when you're typing out all of these things, you're not typing out the word Express, you're typing CPX dot whatever you want to do with it. And I will have, I'll show you all the possibilities for it, and then show some examples using it. And then we will get into the level of simplification that this library does, because I will show you what that same code looks like without using this class. So, alright, so connecting to the serial console. The serial console is basically, there's an output from these boards that when you do a print statement, that is where it goes. It goes to the serial console. And the REPL is actually an interactive, it's called the read, evaluate, print loop. And you can get in there and run code line by line. And it doesn't, you can't save that code, but if you're trying to run your code and you're not sure why it's failing or where, you can start running it line by line, and when it fails, you then know exactly where it was that you had an issue versus trying to sort that out. I will not be demonstrating how to do it on Windows, as I don't have Windows. But you download PuTTY, you find your COM port in your device manager, and then connect using PuTTY with the serial console information. For Mac and Linux, to find your serial port, it's these two things will show you. The Linux version usually ends up being TTY, like ACM 0. The Mac version is TTY.USB modem, and then a long number or a short number, depending on what it's feeling like that day.
So the board is presenting itself to the laptop as a thumb drive and a serial port simultaneously.
Mm-hmm.
It's like there's a USB hub and two devices there. Okay.
Correct. So, for me, I'm going to do ls dev tty.us. And that is going to be my, that's what this is showing up as on my computer right now. So, to connect to the serial console, I'm going to do this the sneaky way. You can tab complete it. This is the speed it needs. This speed is the same for Windows, Linux, and Mac. It's in PuTTY. It shows up as like there's like a speed box, and you just put it in there. For the others, the screen looks exactly the same on Linux. Apparently, you could possibly need sudo, but you'll know obviously if you try to do it and it fails. So right now there's nothing, because there's nothing in the code printing to. There's nothing in the code printing anything. I'm not going to do it inside the while loop because it'll just spam. So here we are. I'm going to save this, and there's our print statement. And it's auto reloads. So every time you save your file, it will reload the serial console, and it will start printing whatever it is you're printing. Now you can get very detailed with this. I have a sensor here that is it's a accelerometer, gyroscope, there's like 3 other sensors in here as well. You can print 10 things at once. It can print all of the numbers. It can print them live, so you know when you're tilting things and that sort of thing. And I will show you exactly that. Actually, it's on this board. In just a minute. So the REPL, you hit Control-C to interrupt. Sometimes it takes a second, and any key to get into the REPL, and this is the REPL. So I can import any modules that are available on the board. I'm going to import board. It's a very handy module because it has in it all of the pins available for use on any of the boards, and you can see all that by doing dir board. So this is everything available to me on the Circuit Playground Express. Notice that a lot of them are actually named for what they are. It's not like that on the others. Most of the others have just pin numbers. They're going to be either digital or analog. There's going to be different protocols that have particular names that will show up on all the boards. But for example, you're not going to have temperature or light on one of the boards that does not have that sensor built in. And to get back to I could do print statements here as well, where it will run whatever code. So I can do math, I can do anything Python can do. I can import things and utilize them from the REPL. So now that I've imported board, I could utilize it if I wanted to, try and write out some code at this second, but we'll do that in a minute. So that's the serial console in the REPL. Moo editor, I believe I have it. Let's see if it runs. It's still beta, so it's not on here. Moo editor automatically finds the serial console and it shows up at the bottom. So we'll see if this actually works. We'll take a look at that later if someone's really interested. Otherwise, I got to go through all the security settings to get it to start up. Basically, you have your editor and it shows up at the bottom. The serial REPL does. For the most part, I feel like if you're here, chances are you will be able to figure out how to use screen. And you are probably better off using an actual code editor because you get tab completion, you get info, and a lot of times, for example, PyCharm will actually catch things before the code even fails. It will tell me this statement does nothing, it's not tabbed appropriately, it's not labeled appropriately, things like that. So it's highly recommended for beginners. However, if you are beyond that, it really makes more sense to use screen in an actual code editor. So to install libraries, which there are a lot of libraries built in. However, if you have sensors or different sorts of things that you can attach to these boards, you need libraries. And to do that, you download the latest version of the library zip, and then you can just drag the whole thing over to your board, and this is what shows up. It's in a lib folder, and it reads everything out of there. Like I said, there's a bunch built in, but these are all things that you may purchase or have, or different things that work separately, and having the libraries is what allows them to work. The reason CircuitPython code is as simple looking as it is because there's a lot going on in the background, and all of that background stuff is contained in those libraries. They're essentially drivers, if you will, for the boards. For the smaller boards, they're both physically smaller and space-wise they're smaller. You have to selectively choose the libraries that you want to use because it won't hold all of the libraries. You'll get a memory allocation failure if you even manage to copy a lot of them over. So whatever program you're using, grab those libraries you need, copy just those over to a lib folder, and then utilize them, and then you can delete them if you want to do something else later. And this is, of course, available on GitHub as well. There is an auto-release that every time there's an update, there will be a new library bundle released, so it's worth looking into fairly regularly, especially if you run into issues. Check to see if there's a new version of the libraries first. Okay, so here's where we talk about the difference between these two pieces of code. So like I said, there's a specific class or a library that's been written for this board to simplify everything, and to use it, you import CPX as it is here. These are some examples of different stuff you can interact with. You can affect the lights on it with cpx.pixels. There's 2 buttons. It has an accelerometer. There are touchpads all the way around. There's tap detection, there's shake detection, there's a switch on it. That's not all that's available. Just didn't want to load up the slide too much. So let me go back to... Okay, so right now on this, I have a simple testing available. So if I press, maybe not, it work. So when your code isn't working, this is when you want the REPL. Okay, so part of it's working. Oh, there it goes. Okay, so what you're seeing right now, streaming right now into the serial output, is the temperature from the temp sensor on it. You're getting the amount of light, which it's dark enough in here you'd need to actually shine something on it to change that number. And we're getting the results of the accelerometer. As I move the board, the numbers change, because it's actually live data. So there's the buttons turn on the lights. There's a touchpad that turns on lights. There's, let's see, what else did I do? There's a touchpad that makes a tone. And there's a touchpad that turns on the little red LED. So to do all that, this is what the code looks like. I've imported time. The reason I use time is otherwise it just spams the serial console and you can't actually read anything it's doing. Other than that, it also prints. Let's comment out the. Okay, so it just reloaded. It prints when I press the buttons. It prints when I touch the touch pads that I told it to print, apparently. It will print when I change the switch. And this is all done with 31 lines of code. And all the available options for this are here, and this is available for every single touchpad. There's pixels, there's the red LED, there's changing the touch threshold. You can play a file, which is a wave file. You can you can play a tone for a certain amount of time. You can start a tone, stop a tone, shake it. There's a switch, there's a temperature sensor, and there's all the touchpads all the way around the outside. That's what's built into the CPX library. And that same piece of code, without using the CPX, it starts to look like this. So we are importing 12 things instead of 2. We have to set up every single thing we're going to use, and this is basically, let's see, there's a slide going on. All your CircuitPython code is going to look basically the same. There will be your imports where you're importing libraries you're going to use. There's going to be any initialization of pins, of sensors, of whatever it is you're doing. And then there's going to be your main code. It can get a lot more complicated than that, but that's the basic format of what you're going to be doing. So with this, I have to set up with that little, the D13 LED, I have to set up the button to accept input, set up the other button to set input, the slide switch to also accept input. I have to enable the speaker to play the tone on whatever one that I put it on. I actually have to set up because it's a sine wave that's making that tone, and this is the math that creates that sine wave. I initialize the touch pads that I used, the temperature sensor, the light sensor, and then the accelerometer is actually using a protocol called I2C, which also has to be initialized on the pins that it is tied to. And from there, the code looks fairly similar. It gets a little more complicated for playing the tone. There's not one line for it, but overall, we're talking about 95 lines of code versus 31. And the goal with that library was to do exactly what I was talking about earlier, which is lower the barrier to entry. You can pick that up, you can type a few things in, and you can get code working and not have to understand yet how to initialize everything, how to figure out what pins things are on, how to set up, different built-in libraries and that sort of thing. So that's one of the things I wanted to show is just that the board has a beginner element to it, but you can very quickly get into a less beginner situation just by using raw CircuitPython and not using the CPX library. So, all right.
Those tabs around the outside of the board, those are actually GPIO tabs that,
Yeah.
and to use them as a touch sensor, you're just putting it in some kind of a high impedance state to,
Yeah, it actually grabs the change in capacitance, and that's why there's a setting for threshold, because if it calibrates when you restart it, but for example, if you have it attached to, say, fruit, because you're doing like a little fruit project, it can sometimes have problems calibrating. So you can set a threshold that changes like the amount that has the threshold of capacitance that has to change before it considers it a touch event. You cannot use it as a GPIO output and as a touch output. You can only ever use one pin as one thing at a time.
oh yeah.
But it's the class is both the regular and the class are designed to deinitialize and not hang on to, or not initialize everything all at once, so you can then have half of it being a touch sensor, and or half of them being a touch sensor, and half of them being output.
Are there any A to D or D to A on board that?
The A0 is actually not a touch output, it's a true analog output. I don't remember whether there's digital to analog. I know that the pins that are, the other 7 pins that are around the outside can do both digital and analog.
Input.
No,
Or
output, yeah. You can, yeah, it's all, I think it's all output. You're not necessarily, it can, I'm trying to think, because obviously it can read sensors, so.
Yeah, how would you, yeah, that's what I'm
Yeah,
interested
no,
in.
it does, yeah, you're right, so, because I could put it using, alligator clips and wire it up to an actual sensor and it will read it, as long as you initialize the pins properly. Just like here, where I told it that the LED is on D13, I would say, whatever sensor is on, A7, and then it would be able to read that sensor, as long as it was initialized properly.
So as an A to D, it's a 8-bit 0 to 5 volt, 0 to 3 volt?
Well, the USB is 5, and this I don't think has, yes it does, this has 2 3.3 volt outputs as well as 5. Most of the stuff that's available can handle both. A lot of the LEDs want the higher end, but a lot of sensors are set up to handle both 3 and 5, depending on whether you're running it, for example, off of a lithium ion, a li-poly battery, which would be 3, or off of USB, which would be 5. There's level shifters included in a lot of things so that you're not running into blowing anything out. But I think it has more to do with whatever you're hooking up to it is what it's pulling, and at that point you would just be checking to see which level it wants, and then hook the power up to either the 3 volt output or the 5 volt to make sure that you're getting the right amount of power. Because it'll take the 5 volt bits actually just come straight off the USB, but if there's a level shifter built into whatever sensor it is you're using, then it really doesn't matter, it doesn't affect it. So, alright.
The demo board that you were using, was it shaped to accept an alligator clip?
These,
right on
yes.
It?
The 2 of these were designed, I should have brought some with. They are designed specifically to accept alligator clips.
That's pretty cool.
The idea being, again, that you don't have to solder to be able to use this board. This one was sort of a combo because you're supposed to be able to, you can sew with it as well, so you can use it in a wearable or something to that effect. There's touch sensors and a couple other things built in on this one, not nearly as much as this, but these are specifically designed to accept alligator clips.
Sweet.
So you can put your sensor on a breadboard, get alligator clips with, breadboard jumper wires on the other end, and just plug it in and not actually have to solder anything to it. I did a project that was a tone piano using key limes, and it was all done with alligator clips, jumper wired into limes.
Actual limes, you're not like another product name.
Oh no, I'm talking about actual key limes, like
Yeah.
the tiny green fruit, or apparently it's supposed to be yellow, but we never get them right. And because the fruit has a capacitive touch to it, and that's when we added touch threshold, actually. So that's the other cool thing about this, is as people run into problems, they come to the community and they say, hey, I'm having this issue, it's not working, and we say, okay, either it's a bug or maybe it's something you're doing, but we sort it out, and when it's a bug, we fix it. So when I initially did that project, I ran into a problem where the threshold was entirely too small. All of them were setting each other off. I could hover my hand over the top of them by 2 inches and actually set off a touch event. And so
Theremin. You made a theremin.
right? So we added touch threshold to the library specifically to fix this issue. And that's the sort of thing that we do. If you have a problem and you come to us and it's a bug that needs to be fixed, we do it. I mean, half the time it happens in a couple days. Depending on obviously what else is going on, but that's part of the amazing thing about it being a giant community and about it being open source, is that kind of thing can happen that quickly. So, next thing we're gonna talk about is, I'm gonna start using, this is the feather board. There is a series of things that are designed to work with it called feather wings, and they are the same shape. You can put stacking headers on this so it plugs right into it if you want to, or there's something like this board that just allows you to plug in multiple feather wings and a feather at once, and then you don't actually have to wire anything on a breadboard, which is really handy. It's obviously doable, but this is much simpler. Okay. I know, on a brand new machine, right? There it is. Okay. So, this code is designed right now to work with this little OLED display. What I've done here is I have imported the 3 libraries needed. The SSD 1306 is the actual display. And then board and bus I/O are necessary to, bus I/O is necessary to use I2C, which is the protocol that this OLED display uses to talk to the board. And board is necessary to identify the pins on the board. You almost always will import board. That's just a pretty standard, you're probably gonna import board if you're doing anything. So I first have to set up I2C. I have to tell it that there's something connected. SCL and SDA are just the pins that I2C uses. That's pretty standard. You will find that same thing printed on sensors. You'll find it on other boards. It's a standard thing for I2C. And then I'm actually telling it, hey, connected to the I2C pins is this little display, and this is where the library comes in, because that library is what's in the background saying, okay, here's all the complicated stuff I need to know about this display, and all I have to do is tell it the display is this much wide, this much tall, and it's on I2C. And then everything else is done in the background. So, the first thing you want to do is make sure that it's working. Which, the best way to do that is just to turn it on. 0 is dark, and 1, I believe, is light. So, focus. We have power to the display, we know it's there. So now what I'm going to do is I'm going to actually put some text on the display, and this is all written into that library, and that's the great thing about libraries in Python, is that it knows when I type this that what I'm trying to do is say hello world, and I don't have to tell it, start the pixel at this point and this point and this point and this point, and identify every single individual pixel to print out the text. And again, to change that, I just update it here, and it automatically updates. Most of the boards have a status LED on them. When things are running and they're happy, it just pulses green. I could shut it off, but I have not. So the other thing on here is a series of neopixels. Those are LEDs. I've already set it up. Once again, import neopixel, I'm importing the library. This just happens to be the pin that this feather wing uses. This is the number of neopixels, and this is turning down the brightness because they are blinding. And what I'm going to do is I'm going to turn them all red. So if I decide, I don't want them all red, I just want the first one to be green. Done. And you could set different ones if you want to. I can change this to be cyan if I'm unhappy with green. I know the green is a little more. Maybe less. Pixels has it's pulling out of the NeoPixel library. it would be a little upset with me if I had, it would change the first NeoPixel if I had both of these going, because it's going in order. So this one is still blue because it comes after it. And that's it. That's what you, that's all you need to do to interact with these external boards. Like I said, there's a number of feather wings. There's that have all kinds of things on them. There's power sensors. There's relays. There's motor, PWM motor feather wings that will run motors, that sort of thing. And like I said, all of them can be wired up with this, or you can use, the little board that just makes it so you can plug more than one in. The one that should theoretically still be running here, this is just a different type of LED. Again, it's hooked up. It's running a library that treats this like a grid instead of one line, which is what it typically does, because it sees it as a strip. It doesn't see it as a grid. Very similar code. The library to do that was actually written by a community member, which again is where a lot of our stuff has come from. So let's see, what else did we? So this is an interactive demo that I created. Doesn't quite fit. Right now, what's running on it is a sound sensor. It's a sound meter, rather. It lights up the LEDs, mapped to, depending on what settings you give it, mapped to the equivalent of the sound level. So I have it set right now to be a little more sensitive because it was requiring a lot of sound to actually set it off. The other thing I have built into this is you press the button and it makes rainbows. And then you press the other button when the rainbow is done. And the lights are now tied to the accelerometer. And I will show you this code in a minute here, where however you move it, it changes the the color and the brightness to equal the acceleration. So since right now it's obviously the gravity, so 9.2, that's all it's adding to the total brightness, but if I shake it, because it's an increased amount of acceleration to it, it gets brighter. So that was just the similar type of code, and I will show you what that looks like. So for the sound meter, I did not do it using the CPX library. The sound meter is a lot more complicated. There's a lot more math that goes into it to basically scale, because sound is not a linear number. So there has to be math that changes it from what it is to a number that can be understood and just displayed on the LEDs. I made them into functions because trying to run all of this code inside of a loop slows everything down significantly. So instead, it's inside of a function, and the only thing that is run later is the function itself. This is how the rainbow is done. You give it a position, which usually you call I, and you give it the number of LEDs that you have, and it goes from there and uses that position to change what it is, and that's how it does the actual spinning rainbow. Is basing it on the number of pixels that you have and the whatever number it's on. So it starts at red, goes to green and blue, and then back to red, with all of them being mixed in between to make a rainbow. The ring is so the internal LEDs are RGB. The ring is RGBW, which means it also has a white component. The difference turns out to be that it has 4 bits per pixel versus 3. So if you try to give it only 3 pieces of information, it starts to get offset because it only gets to 3 out of 4 and then starts into another set of pixel information. About 3/4 of it works and none of it works correctly. So you have to add into the wheel code another 0 because we're not turning on white when we're doing the rainbow. And anytime you have any color utilizing it, like the sound meter and so on, it has to have that extra piece of information. So where did I put that extra piece? here. So this is where I had to put that 0, or the sound meter doesn't work around the outside. So this is what the acceleration code looks like. That's what does this and takes it. So what's going on here is it's taking the absolute value of the acceleration, which is any number between 9.8 or, well, 0 and then negative whatever and positive whatever. Gravity itself is negative 9.8. So at any given point in time, it's one of them is at least 10. They can't all be 0. And then it takes it adds it to 0. So we're starting with no color at all. So the color that's created by this is completely determined by the level of acceleration in the given direction that it is. This one happens to be Z, which is straight through the board. And past that, this is all the setup for recording the sound sample. The sound meter works by recording 160 bytes of a sound sample, then comparing both the min and max of it, and then it extrapolates into how many pixels it lights up. And this is what the code looks like for the rainbow when it's all said and done, because of the fact that I'm using the functions to do it much faster this way. This is the function with the acceleration, and all of this is the sound meter. You'll notice the accept errors. That's simply because I wanted this demo to continue working. It was running into problems, and if it does run into those issues, the code will stop. So if you're looking at the REPL, you would see a memory error, which is like a memory allocation error, an overflow error, or an index error, and the code will stop. So if you wanted to know why your code suddenly stopped working, that's when you would go to the REPL, you would find this. So for this particular demonstration, I just basically pass through all of them. So if they do happen, the code doesn't stop. It's not a great way to do things, but it works for demonstration purposes.
Is that white level a byte, or is it just on or off?
Say, which one?
On the outside, on the W level?
Yeah.
Is it full byte, like, 0 to 255?
Yes.
Okay.
Mm-hmm. Yep, it would, so all of them on would be 255, 255,
Gotcha.
255, 255. And so, yeah, that's how they ended up doing the RGBW. The white pixel
Gotcha.
is actually, looks bigger than the rest of them. It's significantly brighter, but it's still, and even though they have strips that are all white, and it's actually 3 white LEDs, and it's still exactly the same thing. It's all 0 to 255.
Gotcha.
So, the last, let's see what else we have.
How much memory's on those?
Well, that depends, because CircuitPython takes up X amount. I would have to,
Just curious.
don't remember the actual thing. I think it's
You talking about file space or RAM
3.
space?
Well, total land file.
How big, yeah, how big you put on there?
Yeah.
I feel like I'm blocking. I should know this, but.
How'd you escape to the show?
Control C, and then so Control D to get back to it, but Control C will interrupt it and get to the REPL. It's sometimes you have to hit it twice because it's still trying to reset and run the code, but as you can see, since this code doesn't have a loop, it automatically wanted to exit to the REPL anyway, so it's sitting in a state that's much easier to get out of.
So, Kattni, the code we've seen so far, you've got the while true and then a bunch of code.
Mm-hmm.
So that's just polling all those sensors. It's every 0.2 of a second or 0.5 of a second. It just keeps looping through and polling everything.
Yeah.
Is there an event-driven way of doing this where it won't poll, but it'll respond to it if something happens? Push a button and that
Yes.
kicks off some code executed?
One of these pieces actually did that. I don't think we did. Which one did? Yeah. If you don't have the loop, it will only go through it once. But for example, let me see if I have it with me.
Thanks.
Was that 2 megabytes of SPI flash?
Okay, so the SPI flash is 2 megs, and the chip itself is smaller, and I believe that CircuitPython is running on the chip itself, but it uses this, for the boards that have SPI flash, it uses the SPI flash as also storage. So that's how it can hold the libraries and so on. Okay, so this is a piece of code that is meant to work on this board. It looks for 2 single taps, 1, 2, and then it looks for 2 double taps, 1, 2. So we've got just, there's still a while, it's not a while true, but it's looking for tap count, and each time it taps, the tap count increases by 1 before it moves on to the next chunk of code.
Is tapping on what, the touch sensor or the accelerometer?
Nope, the actual board
or-
itself, if you tap it, it's sensed by the accelerometer, but it senses it through the whole board. Again, a lot of tweaking to get that to be happy with threshold wise. So it's a matter, the thing about it is the looping obviously continues going through everything, and if you don't have a loop, or you have something that only runs through once, it's going to run through it once and it's going to be done.
Right.
So this will actually reach the end and not continue, this piece of code. But it is event driven, because until you tap it again, it doesn't go. So the accelerometer on here has an interrupt pin, which sort of works.
Yes, I would think
And
something with interrupts.
interrupts as a whole are not supported yet in CircuitPython. It's not a huge priority because it's a much lower level thing, and right now we're working on building, the higher level side of things. However, there is an interrupt pin on these chips. It is connected, and it can be used. There's different sensors. In fact, this is a gesture sensor. This is here, and it has an interrupt pin, and you can set it to work off of a digital output. It doesn't necessarily use it like you're thinking. That's what we tried to get the accelerometer to do for the tap detection on the Circuit Playground Express. That was 5 days of fighting to find out that the chip is designed weirdly and doesn't really support what we were trying to do. But the drivers themselves do have, for at least the accelerometer that's built into the Circuit Playground Express, has interrupt registers. It uses it. It tries to use it for tap detection instead of using a change in acceleration, which is what would happen if you weren't using the accelerometer. This was in reference to the fact that they're not built in, but they are still easy to use. Yeah. So it's just a matter of telling it what pin you have it on. So if you have a ring or just an LED, a raw LED, whatever pin it's on, you tell it that, and that's how it figures out where it is, and that's how it figures out how to talk to it. Notice the status LED is white.
The neopixels are just strung together on a single serial link.
Mm-hmm. That's why there's a library, I don't know if there's a library for this one, but there's a library for the DotStar one that makes it pretend that it's a grid. So you can tell it to do things on the grid instead of going, okay, I want 1, 7, 16, 22, and 48 to light up. You can say I want row whatever and column whatever, and then it does it. And again, that was written by somebody who wanted to be able to do that, so they did it. The status LED is white. We are currently in the REPL. That's why. It actually does have some handy stuff. If your code is failing, it will blink what line it is failing on. The first thing it'll blink is a light that tells you what type of error you have. Then it will tell you what line it's on. It's very handy. Okay, so.
I bet it can control your furnace.
Right.
Just be careful.
So I want to show that this also because a lot of this stuff looks like it's all built in and designed to work together. You can use it with external sensors. You typically want to safely eject whatever board you're using, or you can, make things unhappy. For the most part, if you know it's not writing, it's fine, but it's just not a good, not the best idea. So, alright. So this is a sensor that has a color sensor on it. It's got a gesture sensor on it. It's got a proximity sensor on it. I will not be demonstrating all of those things, but the gesture sensor is interactive, so I wanted to show it. As you can see here, you are identifying an interrupt pin. I don't think it works exactly like it's supposed to. It does identify it and it tries to use it, and it, as far as I know, this particular sensor won't work without having it wired up. So it tries for the, I think for the, for whatever it is that this sensor uses it, it tries to, but it's, like I said, it's iffy support in CircuitPython itself. So I have imported my library. I have set up my I2C. I've told it what pin the interrupt pin is on, because like I said, this one has an interrupt pin. And without getting into super details, the way this is wired up is that the power is running off of USB. This is my ground. This is power and ground, the little yellow guys, to the actual chip. These two are my I2C, and this is my interrupt. The I2C, like I said, is labeled on every board as standard. There we go. Interrupt is just assigned to a pin, and that's why it says D5, because that just happens to be the one that I chose. So we're going to be using some print statements here, which means we need to connect to the serial REPL. As a side note, if you disconnect from it without actually disconnecting from it, it usually gets unhappy and then just won't let you do anything in that particular terminal window anymore. So the gesture sensor is it's finicky, but you have to be fairly close. There we go.
So you can play Mario with it?
You could. You can do any number of things with it. It's as you can see, it's using IR because it shows up on cameras. It doesn't. You can't actually see IR. But it typically shows, especially on webcams, it does show up, and that's what it's using. So I wired this up appropriately. There was a guide to show me how to do that. This is the code to set it up. This is from the library. The library had examples that explained how to do this. This is for the color sensor and for the light sensor, or the proximity sensor rather. Proximity sensor will work better than the color sensor will right now. There's not enough light.
Is the 3 quotes a convention to comment out the whole block?
Technically, it turns it into a doc string, which acts like it's commented out.
Oh.
You normally theoretically want to put hash marks on everything, but if I'm trying to run through something really quickly, I just do the easier way to do it. And I think maybe I forgot to include part of the code because it's not. No, it isn't. No, it's not paying attention. I'm not sure why. So at that point, I would start troubleshooting. Go back to the guide, see whether I'm missing some part of the example.
What were you with the 3? Oh, okay. Never
Yeah,
mind.
I basically turned, like, I commented this section out and
I
opened
didn't
this
see
section out.
two sets of rules.
Yes, you do need two sets or it does get mad.
Yeah.
What's that?
So, what?
Looks like everything's commented out on this, and two set of blocks.
No, there's,
Oh,
no.
it's on.
Yep, yep.
Yep, yep.
Gotcha.
That's all that's there. So I have another sensor here that will show us some more stuff, and so I want to run through that real quick, and then can answer any questions that anybody has. Answer any questions anybody has right now.
So we were having comments back here about the pricing of various things. We see boards from $10, $25, $15, all these different variations on this. Is there any, I mean, what would the beginner want to start with?
Circuit Playground Express. It's one of the more expensive ones, but it's got so much built into it that you don't.
That's that one?
Yeah, that's just it.
$25.
Well, it's let me not put it with extra stuff. It's this. There's so much built into it that you're not buying a ring of LEDs to attach to this. You're not buying a switch and some buttons and a sensor and whatever to get used to it. It's an all-in-one board. It ships with a demo on it that uses a lot of the stuff so you can see how it works immediately. But it can be wired into much more complicated projects in the end. So you're not limiting yourself by purchasing it in the first place and saying, okay, now I've got this beginner board, what can I do with it? You can run motors off of it, you can do all the stuff that you could do with any of these that run off of these pins. So it really is the best one for a beginner. The Trinket, which is the little one, has a lot of stuff that it can do though. So if you are, on a budget, you're also not really, there's a lot you can learn just by using this. Some of the little pins are actually touch sensors. There's an on-off switch and some more touch sensors built into Gemma. Those are the two cheaper versions of the board, but really this one is the ideal one for beginners. Metro is definitely on the far end of you don't want to get started with Metro. Metro is far more complicated board because you're wiring literally everything that you're going to use. So the SDA and the SCL and these two sensors is swapped, so I am rewiring the breadboard. And when I first plugged it in earlier, I didn't figure that out, and then the REPL told me that there was nothing plugged in, so. So right now, we should be getting some blinking because the code is wrong, because it's not meant for this sensor. So I am getting status lights telling me you're incorrect here, what's the deal? Okay, so this sensor has a lot available. And what it's doing is printing out every single possible thing. This particular demo is printing out every possible thing that this sensor can give you. It's a 9 DOF sensor, degrees of freedom. It's the level of precision with which it actually tells you where it is in any state. Accelerometers will give you just how gravity and acceleration are affecting it. This actually has absolute blocking on the word.
Orientation.
Thank you. There it is. Has absolute orientation. There's a demo that goes with it that has a rabbit, and you rotate it, and the rabbit rotates with you. I don't have that set up. But once again, I quit out of screen without actually quitting out of screen, so I will need a new window. Typically, it stays the same when you plug it in multiple times. It doesn't switch what port it's on. I always check just in case. So as I'm moving it, the accelerometer is changing from here, here to here. The gyroscope obviously is changing as I'm moving it.
There's a
And
magnetometer on it, that's cool.
yeah, this is a pretty complicated sensor. And that's, I mean, this is the kind of stuff you can do. It's just, it's, as long as you can wire this up, which basically means reading what's on the board and lining it up with what's on the microcontroller. And if you're not sure, like I said, there's guides with photos, it's awesome. But essentially, CircuitPython is it goes from the levels of powerful where you can just, you know, be touching a touchpad and it turns on a light, to being able to control the absolute orientation of a project. You could create all kinds of different things. Yeah, so any other questions?
So this question isn't actually about CircuitPython, but it's
Okay.
rather excuse me, about sensors.
Okay.
Do they come from the vendor pre-calibrated? Is there a way to recalibrate them?
It depends on the sensor. There are some sensors that they actually tell you want to leave running for 24 hours the first time you turn them on because it calibrates what it's doing.
Just like leave alone for 24 hours?
Hmm?
Just like leave alone for 24 hours?
Yeah, I forget which one it was I'm thinking of. I'm not remembering, but one of them actually said, you know, that the manufacturer suggests leaving it running for 24 hours to burn in whatever it is that it needs to do. Some of them it is. There's, in fact, we just did a library for a PWM servo motor driver chip, and we wrote a calibration test for it because if you are sending signals to those motors, they need to be accurate, and to figure out what your PWM signal is going to the motors, there was a piece of code written that would send that out so you could test it, because it's supposed to be 100, for example, and if you are doing it and you're finding that it's 102, it's not going to be as accurate as you want it to be. So the calibration code helped you figure that out, and then you would still have to tweak your other code later, but at least you know what offset you need to set later to have everything you're doing being accurate. So
yeah,
it really,
these are motors. If you go too far or not far enough, you have real ramifications.
exactly, and that's part of, you know, that's part of why we did it. But I think it really just depends on the sensor, and I know some of them do come calibrated. Others of them I think don't and need to be calibrated, but I think it just depends on the sensor.
And this is actually about CircuitPython.
Okay.
So do all of the various sensors and things that are not microcontrollers that Adafruit sells, do they all have CircuitPython libraries for them, or
They do
is there
not
still
yet.
some things that don't have CircuitPython support yet?
There are a lot of things that don't have CircuitPython support yet. CircuitPython, we just released 2.0, I don't know, a few months ago. 2.2 was like last week. There are probably, I want to say 70 or 80 that do, but there are, I mean, just breakout boards alone are something like 200 available, and that's not including like separate, you know, I'm just saying like in that category, that's what they have, and we're working on it. That's one of the things a lot of community members are doing, is writing libraries for sensors so that they can use them in their own projects or just to be able to contribute. So that is increasing massively. We've had, I think, 4 or 5 new ones in the last week. I don't know if it'll always be that fast, but it's definitely increasing quickly. There's a separate category on Adafruit that says CircuitPython. Everything underneath that category works with CircuitPython. They're trying pretty hard to keep that updated, so you would be able to know. But you can also check that library bundle that was linked earlier, and if it's in there, it obviously has a library.
Yeah, thanks.
So, yeah.
Does it have support for external Python packages, like stuff from PyPI?
Okay, it has, I don't know specifically with PyPI, but it does have support for some. The problem is that there were issues with space,
Right.
because we are limited, so there's certain things that aren't compatible. Like I want to say,
Like NumPy would probably be very difficult to get
yes,
in there.
that was exactly the one. NumPy is not
Yeah.
supported, but there are other ones that are that are like supported. It just depends on whether, when we brought everything in, was there enough space to do it? And if not, that's like, you know, one of the first things I think that we decided not to include.
Right.
So there's a lot of built-ins, but I don't know all the specifics on which ones they are. Yeah.
How is the gyroscope there implemented? Is it derived from other sensors, or?
How do you mean? Like,
It's showing you degrees per second there. How does it determine?
in this case, it's coming out of the library. Let me see if I downloaded the Pi version of the library. So the libraries are all turned into .mpy files, which makes them smaller. That way we can put more things on the thing. However, there's a new chip eventually coming out. It's the Atmel SAMD 51. We're calling it the M4. These are M0. And it has a lot more space. So there is a version of the libraries available that are all Pi. I thought, no problem. Because that particular board is able to handle them all in Pi versions. So this is what that library looks like, okay? Let's see if I can make it a little bit smaller here. So it's pulling it from different registers. This is what the library looks like that it's running from, basically. Some of it's done using math, some of it's just whatever the sensor is capable of, that's what it's providing. This particular table tells you which things are available for what, whether it's absolute or relative. And then there's that's right. For this one has a whatever the crystal thing is in it that helps it be more accurate. But in this case, it's just something available from the sensor. So it's reading that data from registers, which are identified in the beginning of the library. And this is what any library looks like typically. You'll have possibly some helper classes here. You'll have the main class, which always has an init. It will have various bits inside of it, depending on what that particular sensor needs. And then sometimes there will be more classes available if for example, a particular chip used both I2C and SPI. You'd have two different sections in there to initialize those. That's totally separate pins. In that case, it would be wired completely differently, but the driver has everything in it at the same time. So, yeah.
So, you know, it looks like I'm reading a lot of stuff about like wearable and, you know, blinky pretty stuff and things. Are there, you know, I didn't see anything really about more serious kind of monitoring equipment, that type of thing. Is that?
It's there.
It's there.
Yeah. Making things blink is extremely satisfying, and it works very fast. So it is a lot. I mean, it's like the first thing that that most of us are doing. But there's plenty of home automation, that sort of thing. Where and I mean, people are building. There's a guy who builds these little string car things that are totally autonomous. It's the libraries are there, or rather the guides are there. It's just, I guess they're probably not as obvious because I think the guides actually show up based on popularity, and a lot of people like to make things blink. So, but it is there. The sensors are there for environmental monitoring and that sort of thing, and there are libraries for them. So it's definitely doable. It's just a matter of digging that particular thing up, because there is a guide for every sensor. It's just depending on, because the guides are often written by community, or some of them are written by community members. So if the people that are doing those projects are writing guides, then there will be guides for those particular types of projects. I know there's one guy who's been working on some home automation stuff, and I know he's writing guides for those. So they're around. I think it's just a matter of having to dig them up, unfortunately.
And that can be by these sectors.
Say again?
I mean, where can we buy these circuits?
Oh, so adafruit.com
Okay.
is the website. That's the same place that you will find all the learn guides, and you will find all of the products as well. Like I said, there's a CircuitPython category.
You can also find them over at Micro Center.
You can. So there's resellers as well. I know DigiKey is a reseller, just of ones that are on. But Micro Center is also a reseller, and they've actually started carrying quite a lot of, like a lot more stuff, and it's getting easier to find. For a while, it was very spread out and in weird places. But Adafruit is perfect. It doesn't matter where you buy it from. Adafruit's happy that you're getting involved. So it's not at all an issue to buy from a reseller or anything
They're just
like
as
that.
happy to wholesale them as retail them.
Well, but the thing is the more people that we get involved, the better these products get, and it's sort of the core of open source, and it's one of the greatest things about this, at least that I've found, is just how much of it is built off of that, and how important that has become to be a part of this. You can write anything you want, you can put it out there, but until someone else picks it up and tries to use it and breaks it, you don't know how they're going to use it. You know, I programmed it, I use it a certain way, it works the way I did it, great, it's done. No, it isn't. Immediately someone else is going to pick it up and do it differently, and that's, you need that to be able to have a solid product, and that's sort of the goal with CircuitPython is to be that to be that level of good. We want community members to be involved, and we want to be able to build something that's amazing. Yeah.
Where's the dividing line where someone would choose to use an Adafruit board versus a full-fledged Raspberry Pi?
So, it depends on what you want to do. I don't know specifically the dividing line. I do know that with Raspberry Pi, you have as much memory as you want to put in there on an SD card. So if you're running a huge project, or you need something that is going to run off of programs and not necessarily run just using Python, like CircuitPython, the language, you're going to want to run something on a Raspberry Pi because it's just not possible to do on a microcontroller. If you are working on a project that works with the sensors, that works with CircuitPython, or you decide you want to make another type of sensor work, or like I said, there's people who are running like full home automation off of CircuitPython, so it's doable. It's just a matter of how you want to do it, I think. It's a wide dividing line, I think, because it's two very different things. Yeah.
One of the things too is that you're not running a full OS in CircuitPython. So with CircuitPython, you're running just Python as your REPL. That is it.
Yeah.
That's all you're running, as opposed to with a Raspberry Pi, you can run basically a full-on Linux machine.
So if you don't want to try and set up a Linux machine,
you've got no TCP/IP stack available to
Right.
you. You're not gonna.
Some of these boards actually do have wireless though.
Yeah.
They got Wi-Fi.
Yeah, in fact,
So there is an IP stack in there.
isn't it? Oh, there's one that works with CircuitPython.
I believe so. The Feather Huzzah, which is the ESP8266 chip, actually has Wi-Fi on it, and it is supported with CircuitPython. It's the chip itself is different. The chip itself is what is running the actual wireless. What?
Oh, you said it's embedded.
Yeah, it's right. So, and basically, is do you have all the adapters to run a Raspberry Pi, and do you want to set up an entire Linux install and that sort of thing? And if you don't, CircuitPython is great. If you want an OS and you want memory and you want that sort of thing, then you're going to want to do something with Raspberry Pi or something similar.
Also with power consumption and all that too.
Right. I mean, this is running off of just a light poly battery. You're not going to run an entire OS off something like that for very long.
So on a Micro Center, you have to search for Adafruit Industries. You won't find it under the Python name.
Right. Right. Yeah. No, that's true. When you're looking at the resellers, search through the company name, not CircuitPython. Some of the description on Adafruit says designed for CircuitPython, but it's not part of the title of any of the boards.
I also see something called Developer Edition.
Yeah. That's just what is, that's just what's printed on the back of the board, because for quite a while, there wasn't a lot developed for it. So in buying it, this also runs Arduino. Actually, most of these do. In purchasing this, you were kind of understanding that CircuitPython was still in beta, that it wasn't super developed, and that this board may change. The board is now set. What's on it is on it. The only difference might be that they may release different versions. NRF52 is a different chip. It runs Bluetooth. There may be an NRF52 version eventually.
We're also saying like Arduino compatible V2 is some of the descriptions in.
That's probably for Gemma. There was a version of Gemma that's previous to the one that's here that doesn't run CircuitPython. If you look at the one, if it has tiny holes, it's not the right one. So this runs Arduino. This runs Arduino. This runs CircuitPython. It also runs MakeCode, which is a visual code block drag and drop thing that's based on, it's designed by Microsoft and it's based on JavaScript. It's also very easy to get started.
It's also open source too, right?
Parts of it. But it's, again, if you're getting someone into programming who literally has never done anything and they're not ready to do even CircuitPython, MakeCode is a very easy way to get started. It runs in a browser. You plug into it. It loads everything. You're done. You don't have to install anything to use it. It's really handy in situations where people can't, maybe are using a laptop where they can't install anything. Like schools, for example, sometimes can't install anything on their computers, and so MakeCode is a really good option to get people started in programming. We're good?
When I was growing up, we built things with Tinker Toys and
Any record sets, yeah.
It was surprisingly hard to find Lincoln blocks.
Yeah.
True wood Lincoln
Yeah,
blocks.
yeah, plastic
Yeah.
Christmas.
Cool, thank you very much.
So here's where you can find me. Here's links to various and sundry locations. Read the docs. It's got a lot of information about CircuitPython APIs. Lower level information. It's not a great thing for beginners. However, if you want to know how to use different APIs and that sort of thing, sort of lower level information, it's a great place to go.
Thank you.